Collecting rainwater is one of the standard approaches in order to minimize our water consumption. And so the solutions range from really as simple as putting a barrel under the rain pipe to more sophisticated ones, like installing an underground reservoir with an automatic pump system that then delivers the water for it to be used in cases like toilet flushing or lawn or other vegetation irrigation. Now, how much water can you save by using it for flushing toilets? Well, that very much depends on the individual case. However, one toilet flush can be anywhere between 3 to 6 or maybe even 9 liters, depending on what kind of toilet you have. So if you know how frequent you flush the toilet, you can actually estimate the water saving. Let's distinguish the individual types of water that can actually occur in a building, and now this is based on technical norms which can vary in different countries, but I believe this approach is it should be general. So what is actually considered as drinking water is only the water from the water supply that meets certain criteria, which I'm not going to mention the parameters right now because they vary, or water from a well that also meets certain parameters. Now there are different types of water in the building that are being produced, and we can be speaking about gray water, we can be speaking about black water, and also white water. And so what these are actually? Gray water is produced from things like showering, washing hands, from wash basins. They can sometimes contain chemicals, so let's say use soap, shampoo, or makeup, things like that, and that's why they cannot be easily transformed into drinking water. What you can do actually with gray water is treat it in order for it to become so-called white water. And white water, again, can be used in the building, not for drinking, but for the things such as rainwater can be used for. We're talking about flushing toilets, we're talking about irrigation, things like that. And it's all based on what the quality is, to what level can you get it. Last but not least, there is so-called black water, and you can imagine that's the water coming directly from toilets, which contains all certain kinds of things that can be found in toilets, including toilet paper and others. Now, the question is, can you drink filtered rainwater? And well, technically, I see there theoretically could be a solution. I have never seen it done because the normatives actually do not allow it. And it would probably require a huge investment for the filtration in order to meet the parameters of drinking water. So no one really does that. So to sum it up, as of now, the normatives do not allow any of the following to be used for drinking even after filtration. And these are rainwater, black water, of course, gray water, and not even condensed water from technical systems of the building. Some frequent approaches to filtration, and so it really depends on what the aim for the filtration is. So starting with membrane filtration or sieves, which pretty much just don't allow debris that is bigger than it to flow through. And these are used in pretty much any systems. A bit more advanced is sand filtration and ultrafiltration. Membrane bioreactors usually combine membrane filtration and biological treatment. And when it comes to disinfecting water, there are pretty much 3 approaches that are known to me, and that is UV filtration, ozone filtration, and chlorine filtration. Now I'm gonna run you through footage from a project from 2019 when I worked on the rainwater collection underground reservoir. And so let's dive right into that. The first challenge was actually to get the reservoir to the garden, which looked as follows. And that is now a picture from the balcony. Here is a spot where we wanted to put it. And so we started measuring the diameter and digging the hole itself. Now it was dug all by hand. I had a couple people to help me, but there was no digger used. That is almost finished, and now there is a concrete foundation under the reservoir, which we wanted to reinforce. And normally you would cut out the shape from a reinforcement mesh. However, what was available was rebar at the time, so I just used the individual rebars and tied it in the garage, which was kind of well, it did work. It just required some extra work. Now that's after pouring the concrete. And now the second challenge was actually to put the reservoir down into the hole, which in the end we managed to do somehow. And then what I actually recommend before backfilling is filling the reservoir with water first, so that in any case, so that like potentially it's safe from the soil pressure. However, in this case it was fine. And backfilling with sand is also like the best option here. What I can say further is that we started taking apart some paving around in order for the piping to run. So that's what it looked like. And so this pipe actually runs to the sewage. There is a protection against overflow, so the reservoir has to be connected to sewage in case it rains too much. So that's what it looked like. And we can also see HDPE piping. Now there are three. One is running to the reservoir and two are running to the house. And so I'm going to explain that. One pipe is actually from the pump, for the pump to pump water into in the house for the toilet flushing. And the second one is actually, again, a kind of a protection for the other scenario in case it doesn't rain enough and we need to supply the toilets with something. It's possible to actually fill the tank with supply water, and therefore that's safe. I will say there were actually two individual roof planes led into that tank, and so there is one Geiger installed from a kind of a tool shed in the garden. This is a second pipe from the house's roof. So overflow, Geiger 1, and the second Geiger, there's a T and runs here. It's important so that the pipes have sufficient incline. Good. Now this is all assembled, and as you can see, the pipes to the house run in here. They should be at best below the terrain so that they don't freeze. These pipes are quite okay. That's what it looked like. And now this is pretty much a detail of near the tank. There's some electrical wiring here going on and backfilling it with sand. Yeah, what was actually interesting is that we had to dig under the foundation of the house in order to get the pipes and electrical into the house. And so when we actually put it all together, we kind of reinforced the foundation, and I believe we did pour some concrete. I hope we did pour some concrete over it, but that's what it looked like. And this is the final wiring going to the house. And this is what it looked on the opposite side. We dug the floor out. There are all the HDPE pipes and some electrical. Here you can see I installed this kind of an inspection shaft. Now I really recommend you to install a bigger inspection shaft. This is for sewage, and the diameter was, I think, 400 millimeters. But what this inspection shaft is for is that it actually divides the pipe going from the pump into two sections. And so one section goes into the house for the toilets to be flushed, and the second one goes to the garden, and there is an irrigation system for the lawn installed. And so that's what this shaft is for, as well as that it includes a membrane filtration. So I really recommend you to install a bigger one, because it's a pain in the arse every time one tries to connect or disconnect something there, or simply clean the filter. So put there a bigger shaft. This is a detail of what it looks like. Again, this is the pipe from the water supply coming into the reservoir, and this is from the pump going into the inspection shaft, where it's divided, as I said, and some more electrical there. This is pretty much the final assembly. Now I literally remember laying these pavings the evening before my final high school exams. That was fun. Backfilling. And one last photo from the room where it actually comes to the house. This is where it comes into the house. Now the floor was all dug up. This is an extra thing because we renovated at that time, so I added a central vacuum, but it doesn't it has nothing to do with this project, and it runs there to the technical room. Now that is everything from this project. I hope you install a bigger shaft and don't have to really like crawl up in a tight space as I do sometimes. But yeah, overall it was so much fun. Now the system has been running for more than 5 years now, and there was pretty much only one challenge, and that was with the pump. Now there were two pumps actually, and both were submergible, and the manufacturers said they should function as an automatic system. Was to some extent true. However, it doesn't say anything about the lifespan of those pumps. And so what I highly recommend you to do is whatever pump you install, have an autonomous pressure control system, and at best an expansion tank installed for a system like these. So it's autonomous from the pump and doesn't rely on the pump's electronics, and can be serviced separately. Now there is one disadvantage to installing a system like this that actually was kind of unexpected, and it's specific for the location. However, I'm gonna say that the local sewage or water supply company actually charges money for the amount of water that is being flushed, and it's kind of counterintuitive, but they really did require a water meter to be installed on the toilets, and by that they actually charge the amount for the water that is being flushed, even though it doesn't come from their supply. Now I highly encourage you to do so, but I will still ask the question, would you invest in a rain collection system? Would you be interested in the design phase of a rainwater collection system, meaning calculating the volume of the reservoir and things related to that? Now, thank you for your attention. I'm looking forward to seeing you, not seeing you, in another video. Till then, have fun, be healthy and successful. Ciao. Would you like to drink some?